Hello children, we are doing class 10 science chapter 2 acid, bases and salt important question 5. So in that one first part, write the equation of the reaction for the preparation of A. Sodium hydroxide. We are writing the equation of reaction for the preparation of sodium hydroxide. So in the answer part we are doing when electricity is passed through brine is actually sodium chloride and water. So when electricity is passed through brine, we'll get sodium hydroxide, chlorine and hydrogen gas. So here brine is sodium chloride. Brine is sodium chloride, aqueous, plus water in the liquid form also we are writing. Is when electricity is passed through that one. Electricity is passed through that one. Or this process is called electrolysis. We will get sodium hydroxide, aqueous, plus chlorine in the gaseous form, plus hydrogen in the gaseous form. Plus chlorine in the gaseous form, plus hydrogen in the gaseous form. Now we have to balance this equation. For balancing this equation, write electricity. So sodium chloride is present, sodium is present one time, but chlorine is present 2 times. So we want to make the number of chlorines equal by putting 2 in front of NaCl. So 2 NaCl. So Na is present 2 times, so 2 NaOH. Now, how many chlorine? 2 chlorine. So, 2 chlorines are there. How many hydrogen? 2 hydrogen. 2 hydrogen. How many oxygen? How many oxygen? 2 oxygen. Hydrogen will be 2 plus 2, 4 hydrogen. So, we'll write 2H2 in front of water. In front of water, we'll write 2H2. So, number of hydrogens became 4. 2 2s are 4. Number of number of oxygen became 2. So, 2 NaCl plus 2 H2O gives 2 NaCl plus 2 H2O gives 2 NaOH plus Cl2 plus H2. So, sodium chloride, aqueous sodium chloride or sodium chloride and water, that combination is called brine. So, when electricity is passed through brine, we'll get sodium hydroxide, which is an alkali. Sodium hydroxide. It is an alkali actually. And this sodium is a positively charged particle. So positively charged particle will be collected at the negatively charged rod. That means near, because sodium hydroxide is a big molecule, big compound. So it will be collected near the negatively charged cathode. Near cathode. So it is cathode's charge is negative. Now chlorine gas will be collected. Chlorine is a negatively charged particle. So it will be collected at positively charged anode and later it will escape out or it will be collected in separate containers. So it will be chlorine is negatively charged particle. So it will be collected as chlorine gas, it is neutral. But chloride ion is negatively charged particle. It will be collected at positively charged anode, Anode is positively charged rod. Now next one, hydrogen gas. Hydrogen gas, in small I am writing hydrogen gas. So it will be collected, hydrogen gas is actually positively charged particle. It will be collected at the negatively charged rod. So at cathode. Hydrogen gas will be collected at cathode. Why? Because hydrogen gas is a Hydride ion is a positively charged particle. No. Hydride ion we can't say. Hydrogen H plus aqueous ion is a positively charged particle. So later it will become H plus plus. So when they will combine, when it is collected at the negatively charged cathode, it will become hydrogen gas. So hydrogen is a positively charged particle. It will be collected at the negatively charged cathode. Now next one, preparation of bleaching powder. So indirect question will be there for the preparation of bleaching powder. They will tell you. So one more thing is this process is called chloralkali process. During the preparation of sodium hydroxide, chlorine gas will be produced and alkali is also produced. So this process is called chloralkali process because of the alkali, sodium hydroxide and chlorine. Chlor is for chlorine and alkali is for sodium hydroxide. So I am just writing this process is called chloralkali process. And chlor is for chlorine. Chlor is for chlorine. And alkali is for sodium hydroxide. Now, next one be bleaching powder. We'll continue bleaching powder. For the preparation of bleaching powder, they'll ask you actually a gas produced during the preparation of sodium hydroxide is used for making a white colored powder which is used as a disinfectant. So that white colored powder is actually bleaching powder. The gas produced during the preparation of sodium hydroxide is chlorine gas. So we'll write for the preparation of bleaching powder. And now written the preparation of sodium hydroxide also. So first one, preparation of sodium hydroxide. First one was the preparation of sodium hydroxide. Now next one be preparation of bleaching powder. Bleaching powder is used as a disinfectant. Bleaching powder is used as a disinfectant. Now, so during the preparation of bleaching powder, actually, when chlorine gas is passed over dry slate line, that means calcium hydroxide is the slate line, but it is dry, so physical state is solid. Is passed over, when chlorine gas is passed over dry slate line, bleaching powder will be formed. Bleaching powder's equation is formula is CaOCl2. Is calcium oxychloride in the solid form plus water in the liquid form. Calcium oxychloride in the solid form plus water in the liquid form. Now here, dry slate line. Chemical name of dry slate line is calcium hydroxide only. When chlorine gas is passed over, chlorine gas is passed over dry slate line, we'll get calcium oxychloride. Calcium oxychloride is called bleaching powder. Oxychloride, in bracket bleaching powder. It's a white powder or yellowish. In some cases we are saying that yellowish white actually. So I'll write now white powder. And main use is used as a disinfectant. And water. Now next one, preparation of baking soda, C part. Preparation of baking soda, indirectly they'll ask you, a sodium compound is used for making tasty, crispy pakoras. So sodium compound used for making tasty, crispy pakoras will be baking soda. Actually, some more questions are there. It is used for antacid, and again at the same time it is used for making baking powder, and at the same time it is used in soda acid fire extinguisher. But main questions are written preparation of baking soda, preparation of baking soda. So sodium compound used for making tasty, crispy pakoras, they will tell you. So here, preparation of baking soda. So during the preparation of baking soda, so then brine, sodium chloride. Physical state they are not given in the reader. If you want, you can write the physical state. Sodium chloride reacts with water in the presence of carbon dioxide and ammonia. So we'll say that ammoniacal brine actually. The products will be ammonium chloride and sodium hydrogen carbonate. Ammonium chloride plus sodium hydrogen carbonate. So sodium chloride and water is called brine. Plus water is called brine. So indirectly we'll say when carbon dioxide gas is passed through ammoniacal brine. So you can remember like that. Brine plus ammonia is called ammoniacal brine. NH3 is called ammonia. So when carbon dioxide gas is passed, so carbon dioxide gas ammonia. You will get ammonium chloride. Write ammonia down. You will get ammonium chloride. And sodium hydrogen carbonate. That is baking soda. Sodium hydrogen carbonate, in some cases we'll say sodium bicarbonate also. So here when carbon dioxide gas, for remembering you can say when carbon dioxide gas is passed through ammoniacal brine. Brine plus ammonia is called ammoniacal brine. The product will be ammonium chloride and sodium hydrogen carbonate, which is called baking soda. Baking soda is a base because its pH is greater than 7. Now preparation of baking soda is over. Now next one will come.